right, we have talked about that traditional algorithm with and without regrouping. And now we're going to look at another algorithm that might be helpful for students, and that's the partial sums algorithm. Let's go ahead and get started. With the partial sums algorithm, we're going to work in a different way compared to the traditional algorithm. With the traditional algorithm, you always start in the least place value first. With the partial sums algorithm, we're always going to start with the greatest place value first. So these are some of the steps that can help students solve a problem such as this. You may or may not want to use tools to help students understand the partial sums algorithm. In this example, we are going to use base 10 blocks. In the next example, we will not. So let's see what this looks like. So the first thing we're going to do is draw those vertical lines to separate the place values. And then we're going to show each addend with base 10 blocks. I showed 33 with 3 10s and 3 1s, and 26 with 2 10s and 6 1s. We're going to start in the greatest place value column. In some problems that might be the hundreds place, but not in this problem, it's in the tens place. So let's add 3 plus 2. But we are not adding 3 plus 2, are we? Nope, we are not. We are adding 3 10s plus 2 10s. So 3 10s plus 2 10s is 50. So I'll go ahead and write that partial sum of 50 right there below the equal line. Then we're going to add the numbers in the ones column, 3 plus 6. 3 plus 6 equals 9, so I'll go ahead and write that partial sum below my other partial sum of 50. And then finally, we are going to add those partial sums together. What happens when we add 50 plus 9? 50 plus 9 is 59. So that's an example of how we could use the partial sum strategy to add those two-digit numbers. Now, what might this strategy look like if we're working on a more involved problem such as this? So we are going to do this problem 246 plus 58. So I'm going to get my board lit up here and I'm going to get my marker out because we are going to do this problem in real time. So let's go ahead and think about what this might look like. First, I'm going to draw vertical lines to separate the place values. In this problem, I have a ones place and a tens place, so I'm going to go ahead and draw a vertical line just like that to separate those place values. And then I have a tens place and a hundreds place. So let's go ahead and draw a vertical line right there to separate those place values as well. What's the first thing we're going to do? We are going to start adding with the greatest place value. And in this problem, that's the hundreds place. So here I'm going to add 2 plus nothing. But I really want to focus on the interpretation of this. I don't want to just say 2 plus nothing, right? This is 200 plus nothing. So 200 plus nothing, or 200 plus 0, is 200. That's my first partial sum. I'm going to go ahead and write it right there below the equal line. Then we move and add the numbers in the tens place. What do we have? 4 plus 5. Is it 4 plus 5? No. What is it? You probably said 4 tens plus 5 tens, or maybe you said 40 plus 50. Whatever you said, both of those responses are correct. 40 plus 50 is 90. I'll go ahead and write that right there like that. And you know, one of the things I might do right now is continue my vertical lines, so I really continue thinking about that place value. And then it's time for us to add the ones. Here we're adding 6 plus 8. 6 plus 8 is 14. That's 1 10 and 4 ones. Then what time is it? Well, it is time to add those partial sums. This is the partial sums from the hundreds, the partial sums from the tens, and the partial sums from the ones. 200 plus 90 is 290, plus another 10 would be 300, plus 4 would be 304. So what happens when I add 246 plus 58? Well, my final sum is 304. Okay, it's time to take a pause. I would like you to reflect upon these questions here. First, how comfortable are you teaching this partial sums algorithm to your students? And then second, I'd like you to think about, would your students benefit from using this strategy? And then answer why or why not.